All right. Well, I hope everybody's having a good day. It is Wednesday, and that means tomorrow we have a exam. So you're going to have the entire period to work on the exam. If you're still having any issues, I'll be here at 7:45 in the morning if you want to come in, talk to me about any of these different concepts. Remember, chi-squared, what we've been talking about for several class periods, that is not on the exam. But it will cover cumulative frequency, standard deviation, normal distribution. In fact, we did a focus activity on that yesterday. And it will also have problems on correlation and linear regression. So in fact, going all the way back to say cumulative frequency, would you remember how to find an IQR? What does IQR stand for? Interquartile range. All done? Okay. So interquartile range, how do I find that value? Oh, I'll put it in the tray, please.
Wait, it's the quartile 1 minus quartile 3 minus and quartile 1.
There you go. Okay, Ella has it. It's the value of quartile 3 minus the value of quartile 1. That's the IQR, the interquartile range. So things like that, you want to be looking at. And since I mentioned that specifically, that's one of the oldest topics that we have on the exam. You definitely want to look over that material, but that's coming up. So this assignment that you just picked up on chi-squared, I'm thinking for the rest of the week, we have the test tomorrow. We'll come in on Friday. I'll pass those back. We'll talk about any questions on the exam that you may have, and then I would say for the rest of the period, I'll just let you have that time to work on your assignment. So let's say that's due Friday, or excuse me, Monday. It's going to be due Monday. All right, so you'll notice I do have a couple that I'd like you to go ahead and fill out by hand. The ones on the back, you can just go ahead and use pure technology. In fact, today, finally, will be the first day that I'll show you how to calculate chi-squared on your calculator, the TI Nspire. All right, and then we should be able to wrap this up pretty early next week, and then we're going to move on to our next units, logic, sets, and probability. Okay, so we'll be moving along. All right, now before I go ahead and get started, I haven't told you guys about this yet. Last week, I did have the opportunity to go ahead and create a Remind 101 class for you. So if you're interested in signing up, okay, like, nights before a major quiz or a major exam, I'll go ahead and send out, a reminder about that, or something if I need to get a hold of you very quickly, like, hey, don't forget to bring this to class, homework is due, things of that nature. The code is at 66B83C. At 66B83C. And I've also got it up here on the board beneath Pre-Cal's Remind 101 code. All right. So any questions about what's coming up in the next couple of days, next week? Okay. All right. Well, how about we go ahead and continue with chi-squared. So yesterday, we really actually didn't get the opportunity to talk about chi-squared specifically. It was really more just like a review session with the time we had left. So we've got our observed data. From that, we can calculate what's known as the expected data. So we can refer to it as the expected frequency and observed frequency values. Okay. Any questions on that? Oh, someone not. Any questions on those? Okay. Then we did some examples, and we started to talk about, okay, how do we determine exactly what value does it go from not being independent to being independent? Like, where is the value too large? Well, there were two factors that were going to help me identify that. It was known as the significance level, where you could choose 1, 5, or 10%. And a lot of times the problems will go ahead and say, test this at 1%, test this at 5%, especially if it shows up on a paper exam. But if you're choosing to use the chi-squared test for independence on your internal assessment, completely up to your choice. And that could be part of your paper, explaining why your reasoning, you chose that particular value. The other one is the degrees of freedom. How do we calculate the degrees of freedom? It was the number of, there we go. John Henry's absolutely right. The number of rows minus 1 times the number of columns minus 1. Okay, those two work together to help me figure out what we are going to have. Whoa. Okay, that's interesting. Okay, it just shut down. Let's pull it back up. Nah, don't worry about that. Okay, so all that's booting up. How's everybody?
Great.
Great. Okay, let me see if I can find my slide again. So that when you have everything you need there, this is what I was looking for. Okay, this table. All right. For when you know the degrees of freedom and you've chosen a particular significance level, this is your chi-squared critical value. Okay, this is the value that you're going to compare your calculated value to. The calculated value is what you determine either by hand through the table or using the technology as I'm going to go ahead and show you today. All right, there's just a few minor aspects left, and then we can finally start to pull all of this together. In fact, I believe this is where we stopped yesterday, and I'm going to go ahead and remind you about this importance right here next week during the Yates continuity lesson. Okay. But there is something that we call the p-value. Now, when finding chi-squared on a calculator, a p-value is also provided. This can be used together with the chi-squared value and the critical value to determine whether or not to accept that the variables are independent. So suffice to say, instead of reading through all of that word for word, the p-value is a value that you will not calculate by hand. Okay, but it's always going to be presented when you find it on the Inspire, and think of it as an additional way to confirm the answer that you previously got. And sometimes it's very possible, depending on the p-value, it could actually contradict what you originally thought about comparing your two quantities. Okay, so all of this together, how are we going to know what to say? Well, I went ahead and put everything together for you right here. Okay, I just summed it up. Now, the calculated value, remember, that's the one you're coming up yourself. You're comparing it to the critical value from the table. So if the value you calculate is larger than the critical value, that tells you the quantities are not independent. That means there's some relationship. They have some type of association between them. Okay. Now, if the critical value happens to be greater than the value you come up with, the chi-squared calculated, then that would imply they're independent. That means there's no association, there is no relationship between the two. Okay. Now, extending that for the p-value, you always compare the p-value to your significance level. Now, when I'm referring to significance level, we're talking about the three choices you have, the 1, the 5, or the 10%. But you always compare it as a decimal. So you'll compare it to 0.01, 0.05, 0.1. Okay. So if the p-value provided is less than the significance level, that means they're not independent. Again, there's got to be some relationship there. If the p-value is greater than your significance level, then that would imply they are independent. There's no association between the two. Okay, one in no way would influence the other. Right. So I'll give you a chance to go ahead and jot those down. All right. Now, typically, we won't be spending a whole lot of time with the p-value. I'll probably go ahead, definitely talk about it today. Later on in the year, I'll bring it up again. But odds are it may not show up. Now, I go ahead and say that because up until last year, I had never seen a problem on a paper exam that actually used the p-value. So we talked about this last week. You remember when I first showed you this table right here? I said you didn't have to memorize it, right? Okay, you guys remember that, right? Because I made the incredibly funny joke. Yeah, of course you do. Okay, so probably 9 times out of 10, every problem that I'd ever seen show up on a paper exam or any problem from IB always provided the critical value, because the table is not going to be in your formula booklet. You don't have to memorize it. So overwhelmingly they would have to provide this value, but not always. Last year, for the very first time, they gave a chi-squared problem that did not provide the critical value. Okay, so the question was, well, how are the students going to be able to tell, is there a relationship or is there not? They didn't provide the critical, but they did provide the p-value. Okay, so while the odds are pretty overwhelming that it may not show up, that's the first time in years I've ever seen a test use that. Okay, so it is possible. I don't want to go ahead and say that it'll never show up. Oh, if you'll put it in the tray for me, please, sir. But it's definitely something that we want to be aware of. Okay, we still would like to be aware, if we don't have the critical value, well, what is the p-value telling me about the relationship? Is it independent or is it not independent? Is everybody okay with that? So definitely later on in the year, probably about April, when we're in the middle of reviewing all this material, I'm going to be talking about the p-value again. Okay. Well, IB likes you to go ahead and verbalize what's happening in this type of problem. So when you start a type of problem where you're going to compare two quantities using the chi-square test for independence, they like you to go ahead and write two statements. Okay, the first one is what we call the null hypothesis. This is H naught, so H sub 0. Okay, that's called the null hypothesis. The null hypothesis always tells me that they are independent. That means there's no association, there's no relationship between the two. Now, compared to that, we refer to the alternative hypothesis. Okay, this is notated as H sub 1. This is essentially the exact same sentence, but this one's going to say they are not independent. That means there's some kind of relationship, something going on here. So we always start the problem by looking at these two statements. Okay, and then at the very end, as this gentleman right here is saying, we write, we do not reject HO because rather than we accept HO, it could be performed again with another test level of significance where you could get a different outcome. So IB is going to be really specific on how you verbalize those. This is what we're going to want. Basically, at the end of our problem, we're going to go ahead and say we either reject the null hypothesis or we do not reject the null hypothesis. Okay, you could also use the word association. There are different ways to say it, all right? But we definitely don't want to go ahead and say, well, we accept HO, because that may not be the case at another significance level. So let's just pull it all together. That's a lot of information. Here are the steps. If you ever forget exactly what we're doing, let's go ahead and try a problem. Okay, here we go. Here's an example. Let's go ahead and do all this on the calculator. So it says a survey was given to randomly chosen high school students from years 9 to 12 on possible changes to the school's canteen. And everybody knows what I'm talking about when I say canteen, right? Okay, just making sure. All right. Who said no? Okay, so what are we talking about when we say canteen? Yeah, the cafeteria. Okay. Good old cafeteria, our dining hall. So the contingency table shows the results. At a 5% significance level, test whether the student's canteen preference depends on the year group. Okay, so there's a couple things I would like to go ahead and do here. First, you'll notice I do have a 2x4 grid because a lot of times when you're given one of these chi-squared problems, at the very least, if you're not asked to do it by hand, you are going to be asked to calculate the expected frequency values. Do we remember how to do that? Okay, like say for example, okay, I want to go ahead and find what's the expected frequency value for change at the 9th grade level. Okay, well, how would I determine the expected value for this cell right here? Does anybody remember? 14 times 14? You got the right idea, but we're a little off. What does this table not include? There you go. We need the column totals and we need the row totals. So take a few seconds to go ahead and fill those in. Like this first one right here, that would be 21. Okay, so fill in the rest of the columns, fill in the 2 rows, and let's see how many people belong to this survey. That's always going to go in the bottom right. Okay, so who can help me out here? How many total people were involved in this survey? 85. That's exactly right. 85. Because if I'm looking through the columns, this one right here would also be a 21. This one would be a 22. Then we have another 21. The first row would have a 43 total, and then a 42. Okay, so the final column, the final row should be giving you the same value. Okay, everybody's okay with that? Okay, so has anybody already calculated that first expected value? Someone want to remind me how we do it? Okay, so Ella says multiply. What multiply what? Okay. Now you said multiply the column and the row. So what about the column and the row will I multiply? There you go. Like I'm looking for the expected value for those who favor change in the 9th grade. Okay, so I'm going to multiply that column's total times that row's total. So 21 times 43. Let me come on over here. 21 times 43. I'm going to take that value. I'm going to divide it by what? 85. You always divide by the total number of people in the survey or items, whatever it is. Control divide. Okay, keeps doing that. So what was that? 903. 903 divided by 85. Okay. There we go. So about 10.6235. Okay. 10.62. Okay. Now, that's a good question. Typically, they're going to want the exact values, even though we realize, yeah, you can't have a portion of a person. Okay, you have to have a whole number of people. Yes, so we'll just go ahead and keep it for the decimals right now. But if I were to actually go ahead and answer a question about that, like how many people would be expected to want change in the 9th grade, that's when I would go ahead and say 11. Okay, but the actual value I would go ahead and keep with that. That's a good question. Okay, can anybody help me out with the rest of them? Okay. Or let me just do this. Is there anybody who's still confused about finding the expected frequency values? Is there anybody having trouble with those? Because one of the things the calculator will do is determine those values for you. You just have to know the keystrokes. Okay, so how about we go ahead and do that? Since we're going to go ahead and plug this in the calculator anyway, let's just go ahead and wait to fill those in. Or if anybody wants to tell me the values, Jacob, you good? He's good. Okay. All right. Well, you'll notice I've got these two statements here that I have to go ahead and write, and it's not unusual for them to ask you to write these sentences on the paper exams. What was H naught? Was that the null or the alternative? That's the null. Now, the null statement always says the quantities are what? They are not associated. They're always independent. So it really just depends on how you want to verbalize the statement. Like what I said here, okay, students, canteen, performance, okay, is independent, and I'm just going to abbreviate that, is independent of year group. Okay, there we go. So there's an acceptable sentence for the null hypothesis. Basically, all you're stating here for the null hypothesis is that the two quantities that you're comparing, they are independent of each other. There is no association. Okay. Now, you remember I said a moment ago, these two statements, the null and H sub 1, the alternative hypothesis, they are virtually the same sentence. What's the one difference I can place for the second one? Is not independent. There we go. So students' canteen performance is not independent. So, why not write the whole thing? Students' canteen performance is not independent, okay, of your group. Okay, there we go. Any questions on the two sentences that you'll write? Okay, even on like a quiz or an exam, I'll go ahead and have you practice writing those as well. Okay, all right. Well, we're not going to go ahead. Yes, ma'am.
Sorry, why do you use...
Oh, just, I guess preference, performance. To me, it was kind of the same thing. Yeah. Yeah, I mean, it's not exact, but that's fine. Okay, that's fine. All right. Well, we're not going to do this by hand, so I don't have a little table up here. So this is where I finally get to show you how to do chi-squared on the calculator. All right. Well, here's the thing. We're not going to be going into a spreadsheet like every other concept that we've talked about so far. I need to take the observed data, though, and I need to plug it into the calculator as a matrix. Okay, so let me go ahead and highlight this right here. So this information, I need to plug it in as a matrix. So I'm going to go to the calculator. Okay, so I'm on my Scratchpad screen. Okay, now what I like to do is use this button right here. If you look at the button between 9 and the catalog, it's the open book. This one right here in the middle. If I click it, it brings me up all these nice items, which are very useful to me. Okay, but I want to go ahead and use this second row right here because I want to put in my observed data as a matrix. But if I'm looking at my data, what are the dimensions? And what am I talking about when I say dimensions? The number of rows by columns. There you go, but you were absolutely correct. So this is a 2 by 4. Okay, so you'll notice you've already got several templates over here. You got a 2 by 2, you got a 1 by 2, 2 by 1. Now, if you have a unique size matrix, you want to go into the 3 by 3 because this is always the one that allows you to change it. So I'm going to go ahead and say, okay, we got 2 rows by 4 columns. Okay. And see, it's going to give me that 2 by 4 template. All right. So I'm going to go ahead and plug in my data. So I've got 7, 9, what do we got here? 13, 14. Okay, and then I've got 14, okay, 12, looks like we got 9 and then 7. Okay, so anybody having trouble finding the matrix template, putting your data in? Okay. Now, what we're going to do, use your touchpad, go ahead and get your cursor outside of that matrix, just like I've got here, because we need to go ahead and define this as a variable. Because in just a moment, we're going to go ahead and tell the calculator what to do with this matrix. All right. So if you go ahead and once you got your data in, come over here, click Control, and you want to click the variable button. Okay. Because you hit Control, it's going to allow you to store. You'll notice it's going to give you this little arrow. You can choose to name this matrix any variable you like. Typically, I'm just going to go ahead and choose X. Okay. So is everybody okay with what I just did? Okay, where did I get the arrow from? Let me back up. So once your cursor is outside the matrix, hit Control and then Variable, the button right above the 9. Okay. Now, whatever I put in following the arrow, that is what the calculator is going to know this matrix as. So if I choose X, there we go. So watch what happens. If I just go ahead and type in X and push Enter, the calculator already associates that matrix. It's in the memory. Everybody with me? Anybody need help doing that? Okay, all you got to do now is just follow the keystrokes. Everything is going to be taken care of for you. So I'm going to hit Menu. We're going to go to Statistics. Okay, we're going to go all the way down to Stat Tests. Because remember, this is a test for independence. Now, there are 2 chi-squared tests here. Okay, which one do you think we want? Which one sounds more familiar? GOF or two-way test? Because remember, the very first day we talked about those two-way tables, looking at the rows and the columns, we called those contingency tables. You're going to want the chi-squared two-way test. GOF, that stands for goodness of fit. That is a completely different chi-squared test. You don't want it. Okay, so let me get out of here. How do I get there? Menu, Statistics, Stat Tests. Then I want the chi-squared two-way test. So when I choose that, it's going to say, okay, what matrix do you want to take a look at? Well, I'm going to type in the matrix that I stored previously, X. I'm going to click OK. There's my chi-squared value. See, it gives me the p-value. It gives me my degrees of freedom. There's a lot of information that you're going to be able to pull up here. Okay. Now, you remember last week when we were going through this by hand? Okay, let me go ahead and show you this very quickly. Okay. Like this problem here where we did it by hand, the value we came up with, that's the chi-squared calculated value. Okay. It came up for it came up with that value for me in seconds, as opposed to the amount of time it would have to take me to fill in a table. Okay, so let's go back over here to the calculator. What is the calculated value? 5.8115, let's say 5.81. Okay, so I'm going to come back over here to my problem. Okay, so my chi-squared value calculated is about 5.81. All right, now this problem here, it said we wanted to do this at 5%. Okay, well, we need to go ahead and compare that 5.81 value that I just got to my critical value. Okay, and that's going to help me determine, yes, there's an association, or no, there's not an association. How do I find that critical value? What are the two items that help me do that? Okay, well, we definitely have to go to the table, but there's a lot of values in that table. How do I know which one to use? We need the degrees of freedom. Okay, so the degrees of freedom, all right, we have two rows, so 2 minus 1 is 1, times we have 4 columns, so 4 minus 1 is 3. Number of rows minus 1 times the number of columns minus 1. So my degrees of freedom are 3. And wasn't that in the calculator? Okay, that was provided for me as well. But I also need something else. Ooh, don't need the p-value just yet. Just look at the table. See, I have the degrees of freedom, but now I need my significance level. This problem said I want you to test it at what? 5%. Okay, so now I can figure out what my critical value is. So I'm going to come on over to my table. Let's see, we had degree of freedom of 3. We wanted it at 5%. So the intersection of the two looks like I have a 7.81. Okay, so that is what I want to compare to the value that I just found. So let me write this again. So chi-squared calculated came out to about a 5, what's it, 0.81? Okay, now the chi-squared critical from the table, that was 7.81? All right, okay. 7.81, now go ahead and compare the two. 5.81, 7.81. Okay, well, it looks like 7.81 is larger, right? Okay. My calculated value was less than the critical value that we got from the table. Okay. So now, what does that tell me about my quantities? Okay. What am I going to choose here? There you go. My calculated value was less than the critical, so that tells me they are independent. Okay. So how would we say this? How would I write my answer? Would I go ahead and say we accept the null hypothesis? Okay, good. Remember, we don't want to say that. We say we do not reject the null hypothesis. Okay, so we could go ahead and say that a school's canteen performance and year classification are independent. There is no association between them. Okay. Yes, ma'am. Is it an emergency? Okay, go super fast. All right. So any questions on that? Okay. So we're saying these guys are independent. Okay, I'll just go ahead and put independent right here, if I can spell today. Independent. So according to this information, there doesn't seem to be any relationship between the canteen performance and the year group, the classification. Now, let's go ahead and talk about the p-value. This is like a confirmation. Okay. What was the p-value on my calculator? So let's say 0.121. Okay. So the p-value, boom, the p-value for this problem came out to be a 0.121, and we chose a 5% significance level, right? Okay. We'll compare the 0.121, if I can write this better, 0.121 to now 5% as a decimal would be 0.05. Well, which one's bigger? Okay, so the 0.121, your p-value actually turned out to be larger than the significance level, right? Okay, we'll compare it to, again, this little summary that I gave you. Because the p-value is greater than the significance level, does that tend to agree with what we originally said? Yes, they're independent. Okay. Now, is it possible for that p-value to contradict what you originally thought? Yes, it is very possible. That could happen. Okay. And that's it. That's how you go ahead and determine chi-squared on the calculator. Now, I remember there was one other thing I said we were going to do on the calculator that we didn't bother with by hand. What was I referring to? Okay, the expected values. So here's what you want to do if you want to find the expected values. We're going to come back over here to the calculator. Okay. Now, you notice this button right here that you pushed in order to store the matrix under a certain variable? You don't have to push control. If you want the expected values, go ahead and push that button, variables. And you'll notice you want the EXP matrix, the expected matrix. Okay. So all I did to get here was I chose variable button, EXP matrix. It puts that command right there. As soon as I push enter, it provides me all the expected frequency values for that data. In fact, does one of them look familiar? There's the 10.6235. Okay. And there we go. That is chi-squared. Yes, ma'am. Yes, I can. Okay. So I've got my data here for my chi-squared test. Okay. What button did I go to? Variable. It's the button directly above 9. Okay. So I'm going to click it, and I'm going to choose EXP matrix, the expected matrix. It's going to put that command in my scratch pad. I push enter, and it's going to provide me that table of values. Okay. All right. What do we think? Okay. It looks like what? Sudoku? Okay. Okay. Yes, sir. Ethan. Absolutely. Absolutely. Okay. So let's see here. Let me go ahead and erase all this. Okay. So now this calculator, let's see if it's still, because I erased it. Let's see if it's still in there. Nope, it's not in there anymore. Okay. So let me go ahead and put the data in very quickly. Okay. This is a 2x4. Oh, what was my information? 7, 9, 13, 14. Then we got 14, 12, 9, 7. Okay. So I'm going to go ahead, control store, and you can actually store it as anything you want, but typically a variable will do. Okay, so it's in there as X. Okay, so now I'm ready to manipulate this data and find the chi-squared value. Where do I go? Menu. Remember it was statistics. Then I want to go all the way to the bottom, stat tests. There we go. I want the two-way contingency table test. I don't want GOF, goodness of fit. That is a different test. Okay. So when I choose that, what matrix would you like to look at? Okay, that's the one you stored. And it will immediately type all that up. So just a few keystrokes again compared to what you've already seen us do by hand. Okay. Any questions? Had everything written on it. Yes, ma'am. Okay. There we go, right there. Okay. Any other questions? Ella, I saw you had your hand up. Okay. It was the same. Okay. Yes, Ethan. Then actually, it's think of the p-value as having the final say. So if the p-value does contradict it, you want to go with the results of the p-value. Okay, so that's a good question. That's a good question. Yes, ma'am.
What if the calculated chi-squared value and the critical value are the same?
You know, actually, that's interesting. I'll say I've never seen that happen. There should be a difference between them. I don't know under what circumstances they would be the same. I'm going to have to check with our resident statistician on that one because I don't have an answer right off the top of my head. But I mean, I've never seen a problem where that happens. Okay, it has to be either larger or smaller. Okay. All right, good, good, good. Anything else? Okay. Well, all right. Let's see. 202. Don't think we have enough time to go ahead and get away with another one. So I'll tell you what. I'll just go ahead. We'll stop it there today. Is this on the test? It is not on the test, so we will go ahead and most likely do a problem on Friday just to make sure that you remember the keystrokes and how to do it. Okay? All right, good, good, good.